And I'm back, and this time I'm looking at questions 4 through 7. 5, 6, 7 deal with the same concept. 4 is at least the same prompt. 4 is its own idea, but it goes back to a simulation. And for number 4, we're given a table of random digits, or at least a row in the table of random digits. And it's asking us to perform the simulation. So let's just dive right into question 4. Computer voice recognition software is getting better. Some companies claim that their software recognizes correctly 98% of all words spoken by a trained user. To simulate recognizing a single word when the probability of being correct is 0.98. So right now it's telling us the beginning part. And so you may read this and go, but realize this is telling you in the prompt how you should write a simulation. And that's what I'm telling you, a lot of multiple choice questions are great for learning how to say things properly. Because the prompt has to tell you properly. The question has to tell you properly, which means you can learn from the question how you can say it properly. So it's going to say, let two digits simulate one word. 00 to 97 meaning correct. And then we would say 98 to 99 meaning incorrect. The program recognizes words or not independently to simulate the program's performance on 10 words. So we're going to do 10 words for us. We are going to use this row of random digits, and then the number of words recognized correctly out of 10 is. So I'm going to do 10 words. So I'm going through and I'm thinking about this one for a second. I'm going to kind of write this down. It's going to say, you know what? 00 to 97 means correct. 98 to 99 means incorrect or wrong. So still diving into the idea that this prompt is telling me how to do it right. Now, I'm going to also say one thing. We are writing this prompt based off of probability. And since this is probability, we do not ignore repeats. Because then you're ignoring the fact that the event occurred. I mean, if the event occurred, that means the probability worked. You don't want to ignore that. And so be careful on that. So I'm going to go through, and it tells me we're going to let two digits simulate. 00 to 97 for correct, and 98, 99 for incorrect, for wrong. And I'm going to do this how many times? 10. So we're going to break it. Here's 1, here's 2, here's 3, here's 4, here's 5, 6, 7, 8, 9. And right here, 43 is going to be the 10th one. So now we go through and follow what we said. I'm going to mark C for correct, and I'm going to put in a, F for fail. So 60, yep, correct. Between 00 and 97, yes, yes, yes it is, yes it is, yes it is, yes it is, yes it is. That deserves a big F. Fail. Way to go, computer recognition, voice recognition software. You failed. And then correct for that one. All right, so there's our 10, and we're going to choose our answer. And right now, well, out of the 10 we had, the number of words it recognized correctly was 9. So we're set. That's it. That's your answer for number 4. Nothing too drastic there. You just get our answer 9 by performing the simulation. You just got to remember what it's telling us to do. And remember when it says this statement, they're independent of each other, we have to realize that's giving us a hint that since we're dealing with probability, we do not ignore repeats. All right, question 5 refers to this setting. 1,000 students at a city high school were classified according to both GPA and whether or not they consistently skip classes. This two-way table is going to help us. All right, so this two-way table has skip classes, many and few. It has a GPA. It has less than 2. It has between 2 and 3, and it has greater than 3. So what is the probability that a student has a GPA under 2? So let's look at, in order to do probability, I have to know how many outcomes over the total. And I do not have a total here. So when I'm looking at this one, I'll do totals in green for this. So when I'm looking at this one, I need to make my totals. And so I'm going to do a total column here. And I'm going to do a total row here. Alright, so when I'm looking at this, I have 110 here, I have 890 here, and we were told 1,000. I have 255 here, I have 475 here, and 270 here. Alright, so there are my totals. So now I can go into the problem, because probability is number of outcomes over a total. So probability that a student has a GPA under 2. So that's telling me where to go. So I'm going to use my highlighter and I'm going to kind of focus on it. So under 2 would be right here, GPA under 2. And I'm going to look at this, and it looks like there are 255. I have 255 out of 1,000. 255, sorry. So 255 out of 1,000. So that tells me my answer, go back to the highlighter, is going to be choice B. Well, it wouldn't be a video by Mr. Hansberg dealing with multiple choice questions if we didn't go over why are some of the other choices wrong. So 227 out of 1,000. Choice A. That is 25 divided by 110. That would be this divided by this. That's doing the probability that is not even close to less than 2 on it. Now the decimals are close, but conceptually I'm grabbing the intersection of many skipped classes and a GPA between 2 and 3 and dividing by the total of many. That looks like it's a conditional probability when I'm going through it. 0.450, that would be 450 divided by 1,000. So that's just asking us, okay, right here, how many the intersection. So this would be the intersection of few skipped classes and a GPA between 2 and 3 in 1,000. That's not even close to the question. 0.475. Now, this one at least is doing a general probability for us. It's using this number. It's taking 475 and it's divided by 1,000. So that's the probability of a GPA, a student has a GPA between 2 and 3. Now, that one I would say, if someone read the problem wrong, maybe they would choose D. And then E is 450 divided by 890. That again looks like a conditional probability. It's taking the intersection of a few skipped classes and a GPA between 2 and 3 and dividing by the total of the few skipped classes. So that's a conditional probability there. So B is the answer. Now, what is the probability that a student has a GPA under 2 or has skipped any classes? So you know what? I did a lot of writing here. I'm going to do my best to erase. So what do we have? We had 255 here, and we have 475 here, and I believe 110 there. All right, so now we can continue. All right, so under 2, so let's kind of write down what this problem is actually having us find. The probability of under 2, so probability of less than 2 or many classes. So that's going to be the probability of less than 2 plus the probability of many. But, so probability of less than 2 plus the probability of many, the question you have to ask yourself is there an overlapping? Do I need to subtract the probability of less than 2 and many? And the answer to that question is yes, I do. And we can see that if we go to the table and we highlight the areas we're looking at. So I want the probability of less than 2. Boom, 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 boom. We already found that. 255 out of 1,000. I want the probability of many. And in this case, many would be boom, 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 boom. So the probability of many is going to be 110 out of 1,000. So I have 255 out of 1,000, and I'll put it right here. I have 255 out of 1,000. I have 110 out of 1,000, but notice I counted that 80 twice. So I have to subtract the 80 out of 1,000. And when I do that, my answer for this one, again to go back to highlighting, is C. I'm going to get 285 over 1,000. But again, let's look at our choices and figure out what these other ones are, because some of them might be tricks. And so as I look at this, where does 0.080 come from? 0.080 is looking at the intersection 80 over 1,000. It's looking at the intersection. It's finding the and one. That's what it's finding. It's finding just the probability of less than 2 and many. So that's somebody who confused or with and. That's why choice A is on that problem. Choice B, we'll skip it. Choice C, 0.365. That did not subtract. If I take these numbers, 255 plus 110, I get 365. Divided by 1,000 is 0.365. So this one did not subtract the overlapping. So D is probably one of the most chosen wrong answers, because someone just says, oh, it's an OR probability, I add them together, and didn't realize you counted 80 twice on it. So and then you have choice E, same thing. I'm not going to go into it. So boom, 285, we're good. And now we're going to look at the last problem. Is what is probability that a student has a GPA under 2 given that? Oh, the notorious given that. So probability, let's write this down, of less than 2 given that he or she has skipped many classes. So let's write down the formula to begin this one. That's going to be the probability of less than 2 and many. Where do they overlap? Divided by the probability of many. All right. So we're going to take a look at the table, which means all that writing I did in the table, I'm going to have to erase. So you're going to have to bear with me while I erase it. So all the writing I did, 110, 890, 255. 110, 890, 255. So boom, this is 110, this is 890, and what did I say, 255? And there we go. There's my totals. All right, now we start. What is probably the student has a GPA under 2 given that he or she is skipped? And I said that's a conditional probability, and I have to find the intersection first. That's why I wrote down that formula on it. So let's do that. I need to find the intersection of less than 2 and many. And that's going to be, in this case, the 80. So I'm going to have right here, if I want the intersection of less than 2 and many, that's right there. That is 80 out of the 1,000. Now, I'm going to kind of show this for a minute, is when you're doing this 80 over 1,000, I always kind of ignore the 1,000, 80 over 1,000, because when I want the probability of many, it's going to be the 110 out of 1,000, because that's the total for many. And they both share the 1,000, so when you flip and multiply, they're going to cross out, and I really have 80 over 110. So the answer to 7 is going to be E. That's 80 divided by 110. And again, it's a video by Mr. Ransford. Let's analyze a couple of the choices that could have been tricks on us. Notice choice A. It is the same as choice A in number 6. What this problem does is, this choice says a student confuses conditional with intersection. And this student will only find the numerator on it. So that follows the same idea as number 6. Now, 6 had the person confusing intersection with union, ands with ors, and 7 has someone confusing intersection, ands, with conditional. Now, another one I want to look at is choice D. Choice D is probably one of the most chosen wrong answers. And if I can zoom in and scroll up so we can see it, choice D, which says 0.314, yes, that looks like pi. But the reason why that's not why it's wrong, the reason why D is wrong, and I wanted to talk about this one primarily, is this is the probability of many given that less than 2. Choice D flipped the conditional probability. The order you do the conditional probability matters because it's the probability of event A given that event B occurred. So saying the probability of less than 2 given that the event many occurred is different than saying the probability of many given that less than 2 occurred. So D is a really, it's a trick answer, so be careful on that one. So that's the end of this video. The last video goes over questions 8, 9, and 10.